Hello, this is Nick Andre walking me into another screencast. In this screencast, we're going to be discussing how to convert binary numbers into decimal numbers. In a previous screencast, we actually did the opposite. We went from decimal into binary. In this one, we're just going to simply go from binary into decimal. Let us begin. In order to do this, we're going to do what we did in the last screencast. We're going to set up our place values. I'm going to start in the far right on my second row, and I'm going to call this one the ones place. And I'm going to go from right to left, doubling each previous value, because I'm going from binary into decimal. Binary is my base. And so I go from 1 to 2. The next cell is going to be 4, then 8, then 16, 32, 64, and 128. Now I stop at 128 because each of my octets are made up of 8 bits, but if I needed to convert a much larger number beyond 8 bits, then I would go to 256 or 512 and so on until I have enough places to be able to convert my binary number back into decimal. And I'm following the same rules I did in the previous one. Anytime I'm going to convert a number into decimal, I'm going to write that decimal number in black. If I'm dealing with a binary number, I'm going to write it in blue. And if I'm dealing with place values, that number is going to be showing up as red. So let's start with a binary number. And let's say if I have a number like 1, 1, 0, 0, 0, 1, 0, 1. The question becomes, how do we convert this binary number back into a decimal number, a number that we better understand? So I'm going to start with the very far left, and I'm going to multiply each place value with the binary number. So I'm starting with the 128th place, and I'm going to multiply that by 1, and then right underneath it, 128. And I'm going to continue working my way from left to right, multiplying from top down. So 64 times 1 gives me 64. 32 times 0 gives me 0. 16 times 0 gives me 0. In fact, any number times 0 is going to give me 0. So 8 times 0 is 0. 4 times 1 is 4. And 2 times 0 is 0. And 1 times 1 is 1. Now that I have multiplied these values down, I'm going to add across. So I'm going to take the 128 plus the 64 plus the zeros plus the 4 plus the 1. In order for me to do this, I'm going to come over here on my little scratch area and start that. I'm going to take 128 plus 64. Now I tend to do these things out of order to make math easier for me, but since we're learning this the first time, I'll do it in order. 128 plus 64. Let's see. 8 plus 4 is 12, so I get a 2 down here and I get a 1 up here. And let's see, 1 plus 2 is 3, plus 6 is 9, plus 1 gives me 192. I'm going to add those zeros, which basically give me the same thing of 192. So I usually skip over those zeros and I just add the next value. So I'm just going to add the 4. And I'm going to get 196. And then I'm going to add the 1. And then I get the answer. Or I should say the decimal equivalent to 11000101 is 197. Similar to what we did before, but we're not using any logic. All we're doing is writing my places over the number and multiplying down and adding across. The best way to learn math is by doing it over and over and over. So let's start off with another example. I have a decimal number, binary number, because we're going from binary into decimal. So let's just say the number is 0, 1, 1. Followed by a couple more ones, and we'll do the rest zeros. So there's my binary number. It's written in blue. Now I'm going to write my places above this binary number. And so starting on the right, working my way to the left, I have the 1, the 2s, the 4s, 8s, 16s, 32s, 64s, and the 128. Now that I established my places over my binary digits, I'm going to multiply down. And so I get 64, 32, 16, 8, and the rest are zeros. So now I'm going to do this a little unorthodox, because I know 64 plus 16 gives me 80. And then I can say 80 plus 8 is 88. Oops. 80 plus 8 is 88. And then I can say plus 32. That's going to give me 120. This is just one way. Students have their own way of arriving at the same result of adding up numbers. Some will just add 64 plus 32 plus 16 plus 8. I just did the 64 and the 16 because it gives me a solid number of 80. And then what I could have done on the side is do 8 plus 32. That gives me another solid number of 40. And then 80 plus 40 gives me 120. But like I said, to each is their own. We should still arrive at the same result, that the binary number of 0, 1, 1, 1, 1, 0, 0, 0 is 120 in decimal. And let's do something like 1, 1, 0, 0, 1, 0, 0, 1. Okay? After I got my binary number, I'm going to switch over to my red marker, and I'm going to draw my places. Starting on the right place, I have the 1s column, the 2s, the 4s, the 8s, 16s, 32s, 64s, and the 128. After I have that, I'm going to switch back to my black marker so I have a decimal number. I multiply down, and I have a 128, a 64, 0, 0, an 8, 0, a 0, and a 1. I add across, and then I should get an answer. Well, let's see. In my little scratch pad, I'm going to take 128 plus 64, which is going to give me 192. Then I'm going to add 8 to that. Gives me 200. And then I'm going to add 1 to that, and I'm going to get 201. So 201. So the the decimal equivalent to 11001001 is 200. All right, let me do the last example. Do with another binary number. Let's do this one. 0, 0, 1, 1, 1, 0, 1, 1. Okay. Set my places. First column on the right, put a 1 in there. Then a 2 in the next column. A 4, 8, 16, 32, 64. Now you probably don't have to do these last two here because you know they're going to be zeros, so there's really no need to have them, but regardless. Now we're going to switch over to my black marker. We multiply down. So I get a 1 times a 1 gives me a 1. 2 times a 1 gives me a 2. And a 0. And an 8. And a 16. And a 32. Then these zeros. And we add across. Alright? So I get a 32 plus an 8 would give me 40. 40 plus a 16 gives me 56. 56 plus a 2 is 58, plus a 1 is 59. But let me write it out. 32 plus 16 gives me 48. 48 plus 8 gives me 56. 56 plus 2 gives me 58. And 58 plus 1 gives me 59. That means the decimal equivalent to 0011111 is 59 decimal. That concludes this screencast on converting a binary number back into a decimal number. Thank you for your time, and I'll see you in the next screencast.